You believe it? Week 12. We're coming up on Thanksgiving. Network Essentials. And let me talk about this first. Cyber Defense Tuesdays. Students got working on some projects. Looks like we can go to the Iowa State one. That would be December 6th. We'd go down in the afternoon, and then the competition's Saturday the 7th. Typically done by 4 in the afternoon. So, yeah, let me know if you're curious. We'll, if we get enough people, we're going to sign up. We're already starting some plans. Okay, everybody used DHCP. Everyone had a workstation on the network. On Thursday, they'll do the same thing, except they'll use a static address, okay, from that excluded pool part. And I'll have that on the board. And then I'll also have the diagram so you can write your address on the board so we don't cross over. We access network equipment. We did that by telnetting. And we couldn't telnet to one router, I believe, because of the NAT. But we'll talk some more about that on Thursday. Routing, we took a little closer look. We took a look a little bit at the routing. We talked about some security details. And I mentioned to them packet tracer and some labs. We got one of each of those due on Thursday, and we can cover that a little more on Thursday. You could do those before Thursday. Yeah, they're not ones that have to be done in the class. And we look ahead just a little bit. We've got Chapter 8 they should be working on. Students should be working in Chapter 8. You should be done, or near done, with 6 and 7, and 8. And then we have Chapter 9 right after Thanksgiving. We'll wrap that up in a week. We'll probably maybe start a little bit of that on Tuesday before Thanksgiving. Here we go. What we did today, it's kind of hard to talk about here in a whiteboard review, but I had a PC on the network, and we used that kind of a base point because everybody could see my work. And we did some, everybody got their PCs on. I didn't draw them all up here. And then we were able to ping between the PCs, and then we talked about the difference when you ping somebody that's on the same network. Let me talk about that. So if I was to draw the networks here, here is a network. All the addresses must be on that network. A router would define network. So here's another network here. We have another one up here. And another one over here. That PC would be in there. So the router would define these networks, and in reality this is actually a separate network between there and there also. We'll talk some more about that on Thursday. So when you leave a network, so let's just say we have some traffic, let's say red here, leaves my PC, and I pinged Kara's PC, she was in 4, let's just say this is hers. When it went through the router here, that traffic had to get routed. So it looked at the routing table and figured out where to send the traffic. And if it couldn't find it, that device had a default route pointing to this router up here. And this router has a default route pointing out. So we took a look at that information, and then we worked on using telnet to access the equipment. We could telnet to, in fact we used 2 of them. One of them we telnet to the switches, and we used an IP address in the switch. I had assigned those. And then we telnetted it to the multi-layer, switch, and we used those, they had the address, the default gateway. was the address we were able to use to access that. And then I think it's a NAT issue or something, but I'll have to check why we couldn't get into this router. And then I forgot to mention it, but an interesting scenario here, yeah, could you tell them that to the firewall? Well, you could try, but the firewall should block you from accessing that. So when we were telnetting, that was in-band traffic, inside the bandwidth of all the other traffic. Later on we'll talk about out-of-band. Just talked a little bit inside the routers and switches. They have RAM, and in that RAM they have the operating system, inter-network operating system running, and then they have a configuration, and that configuration has a number of things. And for example, it has IP addresses. It has IP addresses for interfaces, and default gateways are in that configuration, passwords, passwords, I said there's default gateways, and so forth. And you say, where do we learn about all that? Chapter 8 takes you step by step through all of that, how to configure it, and a little bit of what they do, and so forth. And we'll be working on that starting probably on Thursday, up through all the next week. This was fun. I like talking about this. We did an example where, let's say Jonathan and Skylar were going to exchange some data between them, something important they didn't want people to read. So the first thing we talked about, we said you could take the data and send it. Okay? If you just sent the data, how would you know if it didn't get changed in the middle? You know, somebody intercepted it and changed it. Okay, so Skylar doesn't know that. But if Jonathan would hash the data and then send the data and send the hash, when the data gets here, Skylar would use the same hashing algorithm, so he'd get a hash, and then this hash was sent right there, and all you got to do is compare them. If they're equal, the data's okay. All right. Next thing, I use a different color. We'll use red. Lack of anything. Now, if we didn't want somebody to read the data as we're sending it, we can encrypt the data using some encryption algorithm based on some key. So the key allows us a certain way of encrypting the data, and if Skylar has that key, you can't send the key, so you either have to call them or mail it, or they get together and they say, we're going to use this key this whole month for exchanging data. So that's called a shared key. Shared. And there's different ways companies can do this to make sure the key is on each end. So we can encrypt the data. Now the data is cipher data. You can't read it. Then when it gets over here, Skylar can use the key and decrypt the data, and now he's got the data. We got another problem, or another topic to talk about. How can we authenticate this information? How do we know for sure Jonathan is sending it? Well, here's another way. This is a way. There's variations to this. This is I'll explain this just to show you. We could take the data, let's say we add some of his information to it. Maybe Jonathan's first, middle, and last name. Then we add that to the data. Then we hash it. Okay, so now the data has something unique in it, and we create what we would call as a signature, and we send it over. Now Skylar knows that, so then he gets the data, he adds that same signature that he knows they're using, kind of like a shared key, and then he adds that together and he hashes it. This hash comes over, compare them. If they're equal, then it must have come from Jonathan. One thing left. How can we do this? Okay, how can we do this exchange in terms of verifying and encrypting without using a shared keys? You can use a public-private key. Now, a public-private key, if you encrypt with the public key, only the private key can decrypt it. Or if you encrypt it with the private key, then the public key can decrypt it. Did you follow that? What you think about it? So here's what you can do. Skylar can send, let me clarify that. Skylar can send his public key over here, so then Jonathan can use his public key to encrypt the data. Now the only way to see that data is to decrypt it with Skylar's private key, which he would never give to anybody. Yeah, that'll work, won't it? Now, Jonathan and Skylar, they want to make sure this is Jonathan. So Jonathan can take he could take the data and hash it, then encrypt it with his private key. And then nobody else has that key, so there's no other way that could be encrypted by anybody but Jonathan. Then we send that encrypted information over, and we send the public key. So when Skylar gets those two, he can use the public key to decrypt it, and it has to be Jonathan's. Because if it was anybody else's, that public key won't unencrypt it. It has to be encrypted with the private key. All right, that's it. We'll see everybody on the next class period.